talk about RAD, which is Ruby Arduino Development. And Greg Bornstein came up with this idea. He's out of Portland, Oregon. He said, I'm going to take, let me not move out of the screen here. I'm going to take Ruby and use it as an environment to program the Arduino. So it's Rails-inspired, Ruby-inspired. So a lot of the ideas that one sees in Rails every day, we've rolled into this RAD thing. So what is an Arduino? An Arduino is an open source physical computing platform. It originally looked like that. It now looks even smaller, like a nano. That's called a nano, to borrow the Apple parlance. There's 12 digital I/O. There's 6 analog I/O on the thing, so there's lots of ways in and out. In fact, there's even more ways because you can use things like buses. I've got a little demo if we have time for it over there where we're out on an I2C bus blinking we can blink up to 100 different things or sensors. So there's a fair amount of in and out. It's about $35. The most expensive, about $50. Cheapest, you can probably get a little kit for $20. So it's relatively inexpensive. So the notion is you can have a lot of these things around. So what makes RAD interesting? So the first thing is it's a familiar environment. If I didn't bring any shots of the Arduino environment, basically it's kind of a little Java sandbox that you're in there programming, essentially Java, because the Arduino runs on C, C++. And so you're in this environment which was friendly 2 or 3 years ago, but it really hasn't. It's evolved, but it hasn't evolved a lot. But so RAD is in your regular environment. So for me, it's text-made. It could be in any environment that you're using. So it's a friendly, familiar environment. You've got all your tricks. You've got it configured, and it just rolls. Okay. We've extended, I should say, extended configuration by convention. So everybody do Rails or familiar with it? Okay. So all the stuff that you take for granted, like include this or do that, little short snippets that do a lot, is you've basically taken that and extended it to hardware. So, for example, we always have the notions of output pins or input pins on these things, and so you have to declare them and say, hey, output pin 6. And then you give it a name, like Servo. And then you say device equals Servo. The real magic there is really device is a servo. Because when you say device is servo, we know the servos have minimums and maximums. Servos have certain characteristics. We set up a bunch of stuff in the back that you don't need to worry about. So what takes one line like this, if you were to do it on another platform, say Arduino, basic Arduino, you're mucking around with, to use David's parlance, the push-up analogy, doing configuration push-ups, sit-ups, etc. So we basically baked a whole lot in to make it super easy. I'm going to show in a couple of minutes how easy it is, theoretically. So contribution is built in. What am I saying there? So every time we get a device, for example, these are pretty cool. I like these little spectral symbol resistive strips. And you just touch them, and the resistance varies along the strip, right? So it's cooler than, say, a regular pot. But a regular pot, the throttle, you leave it in one place, and it stays there, right? Because it's got a physical interface. When I take my finger off, it doesn't memorize where my resistance was. So we take some software, and we work around it in software, and we take your finger off it, we figure it out, and we put a method together for it, and we wrap it in, and we do an example for it. And the examples, so there's about 30 examples in RAD right now. We test against the examples, so we do a rake test, compile on everything. So you end up with these examples you can peek in. It's as if you were in the Rails world and said, well, I want to look at the authentication examples that are inside Rails. Of course, there are no authentication examples. You've got to plug in and look at those examples. So basically, you have about 30 examples that are baked in. You just go look through and say, oh, that's how that's done. So, and that's going to extend. We're going to end up documenting it, too. Okay. The fourth thing, Ruby. Ruby's pretty cool. It's fun. And it beats the heck out of kind of C-ish language for programming. Now, underneath the covers, since Arduino runs on C, C++, and it's really picky about types, we try to do some good guessing, but we also let you go down to the metal in terms of types. So we've got some facilities for that, because sometimes you need a long unsigned or unsigned long. There's That's a servo. Okay, so let's try it. So what I'm going to do is I'm going to do a standing at program. Let's do it in a new file. Back out. And let's do RAD. Is that font? Yeah, it's pretty good, isn't it? So let's do RAD Meeting. That's pretty good. So I generate the project, and let's do meeting. And so what I end up here, I talked about the examples. They're down there. You've got things like hysteresis, frequencies, things like noise. It's got MIDI. It's got servos. It's got funky strips. A whole bunch of things. The only thing you really need to worry about right now is there's one little project right there, or one little sketch. I'm going to give you a little hint to look at there. So let's just go ahead and do this and say we're going to do the hello world of RAD. Start with the basics and we'll build up on it real quickly. So we're going to take output, use my typing, pin 13, and we're going to call it as LED. That's basically, and inside our loop, and this whole thing is running through this little microprocessor, endlessly looping. And so grab this loop, and let's just say LED blink, and just do it blink every 200 milliseconds. Save that, go over here, break, make, upload, and if it's a good kid, this goes up, it flashes it, it checks the flash, and now, when you use your microscope, you see a little blinking light blinking at 200 milliseconds. So, blinking light. But that's boring really quick, right? Okay, so now let's jump back because I want to interact with this thing. So let's add some more goodies. Okay, so let's do an input pin. And let's do that 7 as, and let's give it a name. Let's figure out where the keys are. Button 1. Let's call it, so here's a little magic, device, and button. The buttons have certain characteristics. We want to save some states, and so we set up some stuff in the background, and we can do some really easy things with buttons now. So now, let's nuke this, and let's do funky blink. We're going to call another method. If button 1 read input. So that's self-explanatory, right? Just basically, and then if blink. And let's do it 30 times. And let's see, LED blink. 5 times 10, something like that. Oh, wrong neighborhood. 10, and I think we're ready there. See if that goes. And we're also working on things, getting better error messages. So you get these error messages, and we improve those all the time. So right now, on my microscopic LED, theoretically, I'll push that button, and I get a funky blink. So it does this whole countdown blinking thing, and we've done that. And now it goes and goes and goes. Okay, great. A board of LEDs. Now we want to move something. So, come in, and we need an input pin. And let's use one as, call it a slider. And device. And I mentioned earlier that I like these spectra strips. I called the device a spectra. And let's do an output. Pin. And so there's number 4, I think, as pointer. My arbitrary name. Device. Servo. Okay, so now you need a variable. And so I was talking with Eric Hodel at Seattle RB, which is where I hail from, and we talked about instances, or variables, and how do we deal with them. He said, oh, why don't we do instance variables, because everybody likes those, they're very familiar. And so we said, okay, the convention is our external variables, our instance variables. So it's not, it should be actually a class variable, but it's typing at twice. Read equals 1, no, 0. Okay, let's go down here and say read slider, and this is a method. You probably have to look through the example support, soft lock. It locks where you let go of the strip. And then let's just say pointer, position, at read. Right? And then this, we're having a debate on this, but right now I have to say servo refresh. And I think we're good. We'll see. You can see a compiler error message in a minute if this doesn't work. Goes up. Looks like it's doing that. So now, theoretically, that servo over there, all our old stuff still works, so our funky blink is still blinking. Theoretically, I think that's monopolizing something there. Oh, there we go. Okay, so now we can take my strip, and I have some, we can do, I'll pull something in. Yeah. Sure. So that's that, and then we played with a little bit of music. So, because music's cool, what should I do? I'm not going to code. How am I doing on time? Okay, so now I'm just going to take a couple sketches that we did, music, because everybody likes music. And then some of these little I2C, they're called Blink M's by Kurt Todd makes them. I'll show you what they are in a second. Let's do some music first. So scales, we're just going to do some stuff on this for scales. And there's scales. I think it should just upload. Oh, so I forgot to describe. So I've got MIDI. The Arduino's putting MIDI out, and I'm pushing it into Logic Pro to set up some reasonably interesting sounding instruments. Servos, they just like to go home. And I've got this little switch here, so because when I upload, it'll spam Logic Pro with MIDI signals. So I'll turn on that. Let's see if the scales are there. Oh, I'm the wrong thing. Doesn't know how to do scales. Let's try that. There. It'll be better. But let's not spam the MIDI. And let's turn the volume up a little bit. I didn't mention there's a couple things that this thing's built on. To do the Ruby translation, Ryan Davis and Eric Hodel did this wacky thing, Ruby to C. And so we take that and we hook into it and we extend it to do some work. Because it does some of the basics, but other things it just it was fairly experimental when they did it. Now, MIDI. Okay, I hear noise. We just need to turn the volume up a bit. So now, so we get a little band action going. And then we got the band action. Now we need to do kind of a funky beat thing, sort of like a sequencer. So we're uploading, hopefully. Oh, I'm going to turn it off. There's our spamming of the MIDI. And then, if you turn it down. I didn't mention you can hook up LCDs. I didn't hook it up just because there's a limit to just hooking stuff in. But it's pretty fast. I think that's the point, one of the points I'm trying to make. So, oh, that's pretty loud. It's on machine gun speed. Let's go down and turn our volume down a little bit. There we go. There we go. So it's the Arduino taking these crude little notes and pushing them into Logic Pro. Okay. So one more trick. I'm going to unplug this. So once again, we don't need any of the computer or anything. The thing's completely self-contained. I'm actually just powering it with USB, and then we're uploading and flashing it. But you could have this battery powered if you want. So let's just hook up these guys. The music's probably going to come right back on, theoretically, right? Yep. Okay. Now, last thing. Nope. I'm going to scan the MIDI. So these guys over here, we're going out the I2C port, and which is a little port typically used for inside computers, but you can actually get some reasonable distance with it. And so the first thing, did it go? We'll find out. I didn't notice. Actually turn it all the way. Did I do that? No? Okay. Oh, I misspelled it. M-U-L-T-I. And then you get really tricky. You put the music and lights and basically you could. Well, this is just, those are actually, I'll pop it off and you can take a look at them. They're actually fascinating little devices. They're microprocessor controlled 3-color LEDs. And so right now we're just powering them. But then right now we're going to signal to them. So let's go and turn them all red. And then I think if I push this one, yeah, there we go. So it's basically it's doing a color chase on multicolored LEDs, and it's just, the code is just another one of these, 10 up to this, iterating through an array. Very, 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 very similar to the other stuff that I showed, but it's the basic same stuff. And these guys, let me take this guy off. It's basically the beach rock that we collected today, glued to things on a ribbon cable, and yeah, that's it. If you go to, let's see, the closing credits, if I will. RADRubyForge.org. Oh, my wife will kill me if I don't do this. You may have seen this. I don't know that. She'll say, "Did you?" And I'll say, "No." So you may have seen. You may have seen this. It's on Ruby Inside and a whole bunch of places. So let's just play that. So this is something about a month ago when I initially got going on this thing in earnest. Because I think I've overpowered everything. Let me shift out of full screen. Window. Okay. We're not going to do that. You're seeing these. It really doesn't do that. It doesn't do it in stop action. It does it in real time, but I'm not going to buy another one of these until the next batch comes out, which is the end of this year. So we're holding on. Anyway, thank you so much for letting me present in what has arguably got to be the best climate in the world here. You guys are just, serious. It's incredible. Thank you. Now what's really doing is we're basically we're taking all this Ruby and keying up and teeing up things, and then we pack it, we basically throw it into C. C++. We compile it. Yeah, that's what you're actually seeing through. We're actually compiling. We take the Ruby. We use it. So the base of this thing, so there's some C chunks that we just know are going to be there. We pile those in. Other things we translate literally from Ruby into C. And we lay out the whole thing, and because we know what device we're working with, we know pin this needs that, and what's needed. And so it's this combination of translating actual Ruby and also some setup. Like, for example, you need to, there's a whole, in C, you've got to declare, you spend half of your life declaring stuff. And so Ruby runs through there and says, oh, let's declare some of this, let's declare some of that. And we put them all into place, and then we compile it. There's a guy I work, Brian Riley, I should mention. Greg Bornstein birthed the project about a year ago. Brian Riley is really the hardware guy, does a lot of C libraries behind it. And he said, so we could do Arduinos. We could do basically anything. Because Ruby's this beautiful environment for setting up, teeing things up, and then smashing them into other stuff. So there's some interesting possibilities from that perspective. Working on it. Actually, the notion is something like shoes. Wise shoes emulator, kind of put a software in it. That's actually one of the next steps. There's a lot of next steps. Documentation where our philosophy has been get things up and operatable, how we would like them, and then we'll kind of mold it in. Because right now, even the syntax, I look back on some of the syntax. Should it really be soft block? No, it should probably be read soft block or something different. So we're mushing it around a bit. That's it. So thank you so much.
That concludes this episode of the SD.RB podcast. See you next time.